So, hi everyone. In this video, we are going to discuss about the round robin or the RRNAS scheduling. So, it is similar to the FCFS or the first come, first serve na algorithm. But in this case, there is preemption. So, if you remember in our discussion for the preemptive na scheduling, there are interruptions that are happening or we are enabling the system to switch between processes. So in a non-preemptive process, right? So once a certain process has started its execution, so that process will just continue on executing until such time that it gets terminated or it switches to another na state, but it never gets interrupted, right? So, but for the round robin, we have a preemption or we are switching na processes. So each na processes is only given a small amount of CPU time or the time quantum usually from 10 to 100 milliseconds. So for example, only 10 milliseconds is given for P sub 0 and it gets switched to another process P1, which is also given only 10 milliseconds, then P2 and then P3. So each of these are given a specific na time slice for them to execute. Okay, so the ready queue is treated like a circular queue, and the CPU scheduler goes around this queue, this ready queue, allocating the CPU to each process for only a time na interval. Okay, so again, we are treating the ready queue as a circular na first in, first out na queue of processes. Okay, so after a quantum expires, let's say after some process has done its execution for some time period, then it gets preempted and added to the end ready of the queue. So assuming that there are end processes, let's say we have 5 processes here and the time quantum is Q, or let's say the time quantum is 20 milliseconds. So each process gets 1 over n of the CPU time in chunks of at most Q time units. So each process gets 1/5 of the CPU time in chunks of 20 milliseconds. So no process waits for more than n-1 Q time units. So yung question is that, assuming that this P1 has already executed for 20 milliseconds, and then there are 5 processes, so P2, P3, P4, P5, which will execute for each for 20 milliseconds, when can P1 execute again? So how many, what would be the waiting time for P1 such that it could execute again? So we can compute that with n-1 Q time units. So to visualize, let's say the P1 already executed for 20 milliseconds, then P2 for 20, P3 for 20, P4 for 20, and P5 for 20. So then the P1 had to wait for n-1. So that would be, so as is yung position niya. So we have to like 4 processes that have to execute for 20 milliseconds. So that would be 5 minus 1 times 20. So 20 plus 20 plus 20 plus 20. So that is equivalent to 4 times 20. That is equal to 100 milliseconds. That means that each of this process have to wait for at least, or no more than pala, not more than 100 milliseconds before it can execute again.